Okay, because I'm looking for that intersection and there is none, we actually will say no solution. Which makes sense because no score that I can think of is greater than 90 and less than 70. So notice how on my actual number line, there's no solutions. There's nothing shaded. That's why we actually shade above instead of on the number line. Our number line is just showing our final answer. Okay, scores greater than 90 or less than 70. So if I look greater than 90, so I have that open circle, and greater than, all my values greater than 90 are to the right. Less than 70, so 70 and less. Now this or means either one of these or both can be satisfied. So x is greater than 90 is satisfied here, and then x is less than 70 is satisfied there. So that would be my final answer. Okay, I actually want you to pause the video and try A through F by yourself and then come back. Okay, I'm still going to use my different colors to represent and paying really close attention to that word in between. And meaning our intersection, where are both of them true? Or meaning one or more can be true. So I'm going to put my number line on. X is greater than -3, so anything greater is to the right. Less than or equal, so because we have that equal sign, we're actually going to color in that circle. And less than is to the left. I decided to lay them on top of each other just so you can see that we're actually shading that intersection. Where do they both overlap? Which is also why I chose the color purple. So where do they both overlap? That purple region. So we could even write that as a single inequality. X is less than 3 because x is bigger, or -3. Less than or equal to 7. So we're combining these two to be a compound inequality. For B, I'm still going to put my numbers there. But now we're looking at or. So greater than -3 or less than or equal to 7. So still shading in that circle. But now, since I'm looking at or, we're looking at what's called the union. One can be true or both can be true. So less than or equal to 7 is true everywhere I see the pink. And x is greater than -3 is true everywhere I see the blue. So I end up shading the entire number line, which is all real numbers. Because if you think about it, every single number you can think about is greater than -3 or less than or equal to 7. Okay. Here, same thing, -3, 7. Here it's less than -3, so less than is to the right. And greater than or equal to 7, so I'm going to color in. Because it's an and, we're looking for the intersection, and what I notice is they never overlap. So that's called no solution. Because there's no number that's less than -3 and greater than or equal to 7. Okay, x is less than -3. Greater than or equal to 7, so still shading in. Now because it's an or, we're looking for the union, meaning one or both could be true. Well, if I look at this section of the number line, my x is less than -3 is true. In the middle, there was no color that I shaded, so none of these numbers are true in either case. And then here, we've got greater than 7 is true. And then last one, second to last one, greater than -3, so that's to the right, and greater than or equal to 7. Because it's an and, I'm looking for where do those colors overlap. If I look in the center, the only inequality that's true is x is greater than -3. Because of that and, I need both to be satisfied, both to be true, and the only time that happens is to the right. So because that's the only section that works, we can also rewrite that as x is greater than or equal to 7. Because I want both of them to be true, and that's where I shaded. All those values greater than 7 work. And then x is greater than -3 is to the right, or x is greater than or equal to 7. So greater than or equal to 7 is to the right again. Because it's an or, we're looking for the union. So one or both of them can be true. If I look at this side of the number line, there were no inequalities that were true, so I'm not going to shade to the left. If I look in between, all those values are greater than -3, so I'm going to shade. And then here, both of them end up being true. So that would be my final answers that work in this compound inequality, which I can actually write as x is greater than -3. I can't write the equal to because that was an open circle. Okay, so to summarize on your back page, and versus or. For an and inequality, we're looking for what's called the intersection, which is where the solutions intersect. Where are both of those colors? Versus an or, it's called a union. And we really want to say where at least one inequality is true. What's important is both can be true as well. Okay, so for the rest of the time, I'd like you to work on part 2, which is completing these by yourself. Just so you know, will not be an answer key available on Haiku, because I really want to make sure what do you understand through the ands and ors, and what do we still need to talk about. Okay, see you tomorrow.